Hey my people, in this video I'm quickly talking about quadratic transformation. And we know that quadratics, they look like this, like a U shape, sometimes a V, depending on how the graph is shaped. Alright, so this is the correct way of drawing it. I know Mr. Howard can draw in a way. So this is the equation that y'all need to be knowing about. Remember? So look, what causes a reflection? What causes a translation? Left and right. What causes a translation up and down? What causes a vertical compression? Which causes a vertical stretch? These are the things that you gotta know. When I say a reflection for the first one, I'm telling you something about a negative sign in front of A. Alright? If I'm talking to you about translations of left and right, I'm talking about H. Up and down, you know I'm talking about K. Stretch or compression. Stretch when A is a whole number. And then when it's compression is when A is a fraction. Alright, so let's go ahead and get further into this. So, a vertical translation. On your exam, I will be asking you which letter represents the vertical translation. And you should be able to say K. So, I will be telling you to go further than that. You tell me when K is less than 0, it goes down. But when K is greater than 0, it shifts up. So long story short, if it shifts down, it's negative. But if it shifts up, it's positive. Horizontal translation. This is what you gotta talk about. So you know I'm talking about H. But we have to be careful with this. Because I know when you see negatives, and when we look in the graph, you always want to go left. But that's not the case when it comes to this translation. So remember, when it's negative, it's going to go to the right. And when it's positive, it's going to go left. I would ask you on your test, why is that? And you would say, because the graph represents the solution to the equation. Let me repeat that again. I will ask you on your test, why H is negative. Well, let me rephrase that, I'm sorry. I will ask you this on your test. Why, when H is negative, it moves to the right? You would say, because, Mr. Howard, the graph represents the solution of the graph. Meaning, when I solve for X, that's what H would be. For example, right here, if I was solving that, or putting in a calculator, I would get something with H being positive 2 by solving it. But we're not going to go into the details of solving it. And again, the graph is the solution of the problem. The solution. So if it starts off negative, when we solve for X, it's going to end up being positive. It's going to move the positive direction. When it starts off when H is positive, when we solve, it's going to be in the negative direction. And it tells you this all right here. So all right here. Alright, so guys, horizontal stretches and shrinks. So look, you don't have to worry about looking at the graph and paying attention to that when you're talking about horizontal stretches and shrinks, because it looks very similar to the vertical stretch, which is far more important. However, you just need to know when you are given a function, when do these things happen, stretches versus compress or the word shrink. So let's fix this. So here, when a is a whole number, it stretches. I do apologize for the horrible writing. I just don't have my pen with me at the moment, so I'm drawing this with my finger. So again, when a is a whole number, like right here, see that a? That's the a being a whole number. It stretches, so it gets thin. This information that I had here is false, so I'm erasing it. Now, when it shrinks, it compresses. But what I mean by compress, it gets thick around. It gets thick from the original function. And that's when you're dealing with the fraction, which we should see momentarily. So I'm erasing this again because what I had down here, that's not true. I think when I typed up when the notes was typed up, they got written backwards. Alright? And here's the final example what I'm talking about in terms again thick. So again, that's not true. These words are messed up, so that's why I'm marking them out. And this is when it shrinks. And again, when it shrinks or compress, it gives you a fraction. So the question of detail I will be asking you from when I'm saying horizontal, or am I saying the y or the x-axis? So if that horizontal shrinks, it's going to go away from the y-axis. I know when we think about horizontal, we think about x, and even sometimes I even get it mixed up. But you don't want to pay that no mind. Alright? Don't fall for that trap. So horizontal, we're thinking about for the y-axis, as this picture says here. So again, compress, it moves away. But if it stretches, it pulls closer. And again, that's when you're given a fraction. So don't forget that when you are given a fraction in front of the x, again, a fraction, that's when it shrinks and it moves away from the y-axis. Horizontal shrinks. And again, the graph, you want to worry about that. You don't have to worry about that when I give you the function of it. Alright, this right here is a vertical stretch or shrinks. Now, remember, if it's a vertical stretch, it moves away from the x-axis. But if it's a vertical shrink, it moves towards the x-axis. So again, stretch means that it's a whole number. B means that it's a fraction. And what I mean by B, I mean the second bullet point. Alright? So, looking at this picture again, if a vertical stretch, of course it thins out, but it stretches away but it moves away from the x-axis. But if it compresses or the word shrink, it's simply moving towards the x-axis. And that's a vertical stretch and shrink. And this example that you see on the right, this is an example of a what? A vertical compress. Because it's stretching towards the x, it's getting closer and closer to x. Alright? Alright. Let's talk about reflections. So, if you see a number, if you see a negative sign outside of the function, like if a is negative, it's going to flip over the x-axis. So anytime you see a negative sign, flip over the x-axis. And that's what you need to worry about. Alright? So if the negative sign is inside the function, inside and not on the outside, inside the parentheses, I'm saying, it reflects on the y-axis, but it stays the same. And the reason why this is because, guys, think about it. For example, if x was negative 2, times, or negative 2 times, trying to draw this well, negative 2 equals a positive 4. So as a result, it should stay the same. So that's why it stays the same. Describe this transformation. You will see this definitely on your test. So let's talk about it. So you could say this. I know you guys want. So it moves 1, 2, 3, 4. So it moves to the right 4. And then up 1. So the question I would be asking you after you do that, because that's one part of the question I would ask you, I would ask you to just create the function for that. So using what you talked about, right 4 up 1, you gotta create a function. So it's gonna be x. Because it went to the right, it started off negative. Plus 1. And why is it negative, but it ends on the right side? Is because when we solve for it, it ends up being x equals positive 4. And again, the graph is the solution of the function. And that's if we was to solve it. So describe this transformation. Now I'm giving you a function. Now you gotta describe it to me. So you don't have to graph it, just describe it. Because you won't have a calculator to do that. Up 1. So it's negative 3. I know you guys want to say left 3, but remember, it went to the right. Because when you solve it, it's going to have some positive 4. And then You could say horizontal stretch by 7 and reflects vertical reflect. No, you can't say vertical reflect on X, but vertical stretch by 1. Now we could describe this going from K all the way up to A. So K is up by 1, H is right by 3. Alright? And then the 7X will be stretches horizontally by 7. And then the A in front being -1 reflects on X, but vertical stretches on 1. And that's how you do quadratic transformations.